All right, so today we're doing the dot product, which is a new operation. So what is the dot product? It's defined as if you have two vectors, a1, b1, and a2, b2, their dot product, you take the two x's, multiply them together, add them to the two b's, multiply together. So a note here, you're not going to get a vector, you're going to get a real number. So like your answer will be 2, or 10, or -5, or 0, but you're going to get a number. So it's going from a vector to an actual number. And the dot product is an operation. So think of it like addition, subtraction, multiplication, division. It's an operation or something you do to something. So an example or two. So here, if we wanted to find u dot v, we're going to take 3 times 4 and then add that to -2 times 10, or 5. Add that together, and your dot product is 2. So try this next one, and then check with me. Okay. So u dot v again. 2 times 5 plus 1 times -6, 10 minus 6, and you'll get 4 as your answer. Properties of the dot product, how it behaves. So it's going to act like multiplication. So it doesn't matter which order you do it in, it'll end up the same. If you have, like if this was like a 3, you can distribute it in first, or you can do one first and then the other first. It doesn't really matter. Same thing here, like I can distribute that, do those first, or I can add them together first and then do the dot product. It doesn't matter. The new thing here is this. So the magnitude squared is going to end up being the same as the dot product. So what that actually means here, magnitude squared is not the same as the dot product, so it's not like the same concepts. They're equivalent. So equivalent means that they're equal, like they give you the same number, but they're not the same thing, if that makes sense. Okay, so dot product theorem. This says that if beta there is the angle between two non-zero vectors, then your dot product is equal to the magnitudes times the cosine of that angle. So you can go back and solve and get like this. Your angle has to equal cosine inverse. So this is saying if I have u and I have v, this is your beta. It's the angle in between those two. So an example here, we want to find the angle between them. So your angle is going to be cosine inverse of the dot product over the magnitudes. So let's find all the different things. The dot product, we're going to take 2 times 4, so 8, plus 5 times -3, so -15. And then on the bottom, you want square root of 2 squared plus 5 squared times square root of 4 squared plus -3 squared. Keep going, or you can type it in all at once if you want to. You'll get -7 on top, square root of 29, and 5. Type it in again, and you should get 105 degrees. And that's it. Okay, so orthogonal, next concept. So it means perpendicular, or 90 degrees to each other. So something like this, you have a u and a v, and they're at 90 degrees. Here, if they're both non-zero and they're perpendicular, your dot product is going to equal 0. If your dot product equals 0, it means they're perpendicular. The why reasoning is if you think of our angle here of u dot v over our magnitudes, here this is saying this is 0, right? Which then makes the whole thing 0. So you get your cosine inverse of 0. Well, that's 90 degrees, which then means it has to be a perpendicular thing, or perpendicular vectors. So to check that here, just find the dot products. So u dot v, you have 6, and -40, you get -34. This would be not orthogonal or not perpendicular. we do the same thing for the next one, 2 times -1 is -2, plus 1 times 2 is 2, we get 0, so this would be yes, orthog. And check Schoology for the assignment.